What's up everyone, Luke here from Solid State Logic, and today we're proud to introduce to you the SSL 18, the head of state in our celebrated line of USB audio interfaces. Building upon the success of the SSL 2 and 2 Plus Mark II and the SSL 12, SSL 18 raises expectations for what 19-inch USB audio interfaces are capable of, with exemplary audio performance and a studio session-ready feature set that caters for engineers and producers who demand the highest possible standards for their music. Its effortless integration with other professional equipment makes it the ultimate centerpiece for the serious project studio, whether you're recording, producing, or mixing. The 18 doesn't need flashy gimmicks, just that world-class, rock-solid SSL sound that we all know and love. The 18 is a 26-in, 28-out high-performance USB audio interface that lets you get studio-quality audio into and out of your computer with minimal fuss and maximum creativity. The next generation 32-bit 192 kHz converters provide the platform for SSL 18's analog design to shine, with unrivaled dynamic range performance of 120 dB across all microphones, line level, and instrument inputs to capture your sources like never before. The 18's capabilities are further extended with the power of SSL 360, where the 18 mixer page allows for super low latency headphone mixes, flexible loopback functionality, and talkback input with its own SSL listen mic compressor built in for extra creative opportunities in your recordings and mixing sessions. The SSL 18 also features alternative speaker switching, flexible headphone outputs that can be reconfigured to work with any set of headphones, and the ability to repurpose outputs 9 and 10 as analog insert sends on inputs 1 and 2, perfect for tracking with analog processing in line. Designed by the same engineering team behind the esteemed range of analog and digital mixing consoles, SSL's rich heritage and know-how for multi-track audio is laced throughout the design. From the class-leading microphone preamps to the choice of industry-grade components like Alps pots and Nutric connectors, SSL 18 delivers the kind of quality you'd expect from a world-class recording studio directly in your studio. So let's now look at getting your new interface set up on your system so you can begin using the SSL 18 as the new centerpiece of your studio. Before connecting your new interface, we need to download SSL 360 as this is the software brain for your interface, and this will act as your software mixer and routing matrix for headphones and settings. To register your product, head to solidstatelogic.com/get-started and follow the on-screen instructions. During the registration process, you'll need to input the serial number of your unit, and this can be found at the label on the base of your unit. By registering your SSL USB audio interface, you will now have access to an array of exclusive software from us and other industry-leading software companies. We call this bundle the SSL Production Package, which includes DAWs, plugins, and a host of other useful software to help make the most of your new interface. Once you've completed your registration, all of your software content will be available in your logged-in user area. You can return to this area at any time by logging back into your SSL account at solidstatelogic.com/login, where you can download the software anytime you're ready. Next up, we need to download SSL 360, which is available in your user area's download section for the SSL 18, or via the SSL Downloads Manager, which will give you access to all of your 360-powered software and plugins. You can download the manager from the Downloads page on the SSL website, and will give you access to the latest updates and downloads as they're released. Now we have everything we need, let's get set up in the operating system. So, for using your SSL interface with your Mac, you can simply plug in the interface with the provided USB-C type cable and head over to your system settings. And under the Sound tab, select your SSL interface for both the input and output device, and away you go. Now, in your DAW, make sure you also select your SSL interface as your input and output device, or select System Audio to follow system settings, and now you can use your new interface. For more information on using your SSL interface, you can also head over to the SSL 18 page on the Solid State Logic support site. For using your SSL 18 interface with your Windows system, we need to download the SSL ASIO-WDM drivers from the Solid State Logic website. So jump over to the SSL support pages to grab the latest version, where you'll also find the user manual to help get you started and guide you through the installation process in more detail. Once the drivers are installed, open up the SSL USB Control Panel app and go to the ASIO Devices tab. Link your SSL 18 to SSL ASIO Driver 1. Next, head over to the Buffer Settings tab, where you can decide if you want to have safe mode enabled or not. Unticking safe mode will reduce the overall output latency of the device, which may be useful if you're looking to achieve the lowest possible round-trip latency in your recordings. However, unticking this may cause unexpected audio clicks and pops if your system is under strain. You're now good to head into your DAW and start working with your SSL 18 as your audio device. Now's the time to connect and switch on your SSL 18. First, make sure that the power is attached, then connect your new SSL 18 to your computer via the provided C-type USB cable. If your system uses the older USB A-type socket, we've included a handy adapter in the box. Once plugged in, switch on the interface via the power button on the front right of the unit, and the 18 should spring into life with a white glow behind the power button and a white USB connection light in the display screen to indicate a positive connection to the host computer. Back in 360, the SSL 18 should now be available on the home screen. If any updates are required, such as a firmware update, or if on a Windows machine and the USB ASIO/WDM drivers require updating, then these will appear in the home screen, with the firmware underneath the interface avatar and the USB drivers below the 360 logo. The 360 home screen gives us control of all SSL 360 powered controllers, interfaces, and access to the plugin mixer for 360 powered plugins, with pages to connect each connected unit on the left hand side. We'll take a closer look at the SSL 18 mixer later in the video, but let's first jump over to the interface before we dive deep into the routing options and extended controls available on the 360 mixer. Let's look at connecting up your gear and get recording. First off, let's look at setting up your monitors. Assuming outputs 1 and 2 are our primary outputs in your DAW, outputs 1 and 2 on the 18 will be your main speaker outputs. So let's take a pair of TRS jacks and take the outputs 1 and 2 of the 18 and connect them up to our monitor inputs. And now we should hear audio playback from our system. We can control the volume with the blue knob here on the front. It's also worth mentioning that we have the ability to switch outputs 1 and 2 and 3 and 4 between +9 and +24 dBu in the settings menu, with 9 probably being more suitable for most active monitors. Whilst we have audio playback, let's look at the headphones. We can connect our headphones using a 1/4" jack connector to either headphone output here on the right of the interface, with level controls for each headphone output located here above. We can change the headphone output modes for each output to best suit your headphones in the settings mode, which we'll look at later in the video. By default, these will be set to follow mix 1 and 2 in the 360 mixer, so the headphones are sourcing your control room mix, but this can easily be disabled at the point you start doing custom headphone mixes. Underneath the monitor level controls, we also have 3 buttons labelled Cut, Alt and Talk. Engaging Cut will mute your monitor output signal. Alt will switch the monitor output signal to a secondary pair of monitors if connected to outputs 3 and 4 on the rear of the interface. And Talk will engage the Talkback mic input, inserting the Talkback audio into the 360 mixer, more of which we'll look at a little later on. Now we have our monitoring sorted, let's look at the inputs. As we know, we have 2 mic pre's on the front of the panel and a further 6 on the rear. All analog inputs can be switched between mic and line level, with the added benefit that the preamp is bypassed when in line level. Additionally, inputs 1 and 2 on the front can also be switched into instrument mode. These are specifically set up for high Z sources such as direct electric guitar or bass. The high Z sets the correct impedance to allow us to record the instruments without an amp, and then we can utilize amp modeling sims in the box and have greater control options later on. To engage the high Z option on channels 1 and 2, we need to access the 360 software, which we'll look at later in the video. Control for each input is presented across the front of the interface, each with up to 67 dB of gain in mic mode and 17.5 dB in line mode. The metering and control display for each channel input is grouped on the large LED display here in the center of the interface. We can select which input to control via the button underneath the individual gain pot, then selecting one of the 4 option buttons on the left of the screen to toggle each parameter to the selected channel. As standard, we have +48V phantom power for active ribbons and condenser microphones, the line input switch to change the input between mic and line level, a high pass filter for removing unwanted bass and rumble, and the 4K button. Engaging this switch allows you to add some extra analog magic to your input when you need it. injecting a combination of high-frequency EQ boost together with some finely tuned harmonic distortion to help enhance the sound, inspired by the kind of extra character of the legendary 4000 series console. These controls can also be customized on the SSL 18360 mixer page to allow you to access polarity flip for each channel from the front panel, which we'll look at a little later on in the video. Now let's flip the unit round and take a look at the rear connections. Starting on the left, we have the IEC power connection, followed by the BNC word clock output for syncing external digital equipment. Next, then we have the USB-C type connection to your system and a pair of mini jack TS MIDI in and out connectors in Type A format, allowing MIDI information to be both recorded and sent out to trigger synths, drum machines, or any other MIDI controllable equipment you have available in your studio. Next up then we have the SPDIF digital input and outputs provided on coaxial connections and can operate at sample rates up to and including 192 kHz. Then 4 optical ADATs that allow for up to 16 channels of additional digital audio inputs and outputs at 44.1 and 48 kHz, or 8 channels at 88.2 and 96 kHz. The second set of optical ports can also be reconfigured as SPDIF if you need your 2 channels of SPDIF I/O on optical rather than coax. The SPDIF I/O can be configured in either coaxial or optical ports by the SSL 18360 mixer, and we'll dive into this further in the video. Next we come to the inputs labelled Insert Return 1 and 2. These are dedicated return points in the recording path for inputs 1 and 2, which can be used to incorporate external processing when tracking, maybe with a dedicated EQ or compressor or effects unit before the audio is captured into your DAW. These sends for these insert points are created by hijacking what would normally be outputs 9 and 10 and moving them to the input path, hence the dual labelling of 9 or send 1 and 10 or send 2. Then, when you're done tracking, you can reconfigure them using 360 back to being outputs 9 and 10, giving us 10 outputs from our DAW including our main monitor outputs. Outputs 1 and 2 are primarily to be used as your main monitors, and the physical volume is controlled by the monitor knob on the front of the interface. Then outputs 3 and 4 can be set up as a secondary alt pair of monitors, which are switchable to be controlled by the monitor knob when the alt button is engaged. Both these sets of monitor outputs can be switched between plus 24 dBu and plus 9 dBu via the SSL 360 mixer, and outputs 5 to 10 are fixed at professional plus 24 dBu output operating levels. Also, all outputs, including the headphone outputs, are also DC coupled and able to send plus and minus 5V signal to allow CV control to semi-modular synths, Eurorack and other CV-enabled outboard effects. The Talkback input has a built-in preamp with 3 fixed gain settings to choose from, again in 360. It can be set up at values of 30, 40 or 50 dB with the addition of plus 48 phantom power if your Talkback microphone requires it. What's also really cool is that the Talkback input can be switched to line input mode using the TRS jack connection, which is helpful if you want to use an external Talkback mic preamp, or this can also be used creatively for reamping purposes in sterile stems for that classic smashed compressor effect. In your DAW, the Talkback input will show up as an additional input, so simply send the audio you wish to process from a DAW using one of the SSL 18's outputs and bring the signal back into the Talkback input via TRS jack and see what extra colour the LMC can bring to your tracks. And finally, the rear 6 combo jack XLR inputs for channels 3 to 8 are located here, with the XLR input for mic level and jack input for line level, switchable via the front panel or 360 mixer. So that's a full overview of the physical interface connections and controls. But now, let's jump over to 360 and take a deeper look at the SSL 18 360 mixer and how we can use the extensive routing controls to power near zero latency monitoring, door routing, and extensive hardware control, all from the SSL 18 mixer. So let's jump into 360 and locate the SSL 18 mixer on the left-hand side panel. Clicking on the tab will open up the SSL 18 mixer and we'll be presented with the channel inputs and routing controls by default. We can customize the view in the mixer with the options on the right to select between the analog and digital inputs, Playback Returns and Aux Masters. But for now, let's keep the analog inputs visible and close the rest by deselecting the options to hide them. So with just the analog inputs in view, let's take a look at the channel strips. The meters indicate the incoming signal level to the channel in green, with a red segment at the top of the meter to indicate any clipping of the inputs, which we can click on the meter to clear the clip indication. Next to the meter in this top section, we have the toggle switches for plus 48 phantom power, line, high pass filter, polarity invert and 4K functions, which can either be controlled from the software mixer, or if selected on the interface front panel, the mixer will reflect that state also. As we're looking at channel 1 here, we also have the instrument option, available on channel 1 and 2, that engages the high Z input for recording instruments such as bass guitar. This option is only available in the software mixer and will be highlighted in yellow when enabled. Below the 4K button, we have the Mix Routes Off button. Mix Routes Off is a convenient way of preventing the input signal from this channel entering the SSL 18 mixer section below. You'll see as I press this button, the rest of the channel strip is greyed out to illustrate this. The signal is still sent to the DAW, but Mix Routes Off is simply a clean way of preventing any accidental contribution of this channel to any monitoring or headphone mix, particularly useful for inputs you might be using as part of a hardware insert setup, for example. For now, let's toggle Mix Routes back on and proceed to take a look at the Aux Sends section. This is where you can create independent mixes for headphones A and B and line outputs 3 and 4. The green knob controls the set level for each aux bus. The mute obviously mutes the send and illuminates red when activated. And finally, pan control allows you to determine the pan position for that send when we first engage the pan, then use the blue pan control to determine the left-right balance. If pan is not engaged, then the send follows the main monitor pan control in the fader section. Quick tip, Shift plus mouse click sets the send to 0 dB and Option click on a Mac or Alt plus mouse click on Windows sets the send to off. Similar to the headphone sends, the line 3/4 sends allow the signal to be routed to outputs 3 and 4 with the same level, pan and mute controls. When the line 3/4 Aux Master is stereo linked, a single set of controls for pan, level and mute are presented. When the line 3/4 Aux Master is split into dual mono, independent level controls appear for each channel, one for outputs 3 and one for outputs 4. To split into dual mono, the link button at the bottom of the line 3 Aux Master must be disengaged. Next we then have the scribble strips. These are the text boxes on each channel identifying its input or output type and number order as default. These text boxes are editable, allowing each channel in the 360 mixer to be renamed by the user and can be edited by simply double-clicking on the text box and typing in your preferred name. Below this, we then have the pan control, which determines the position of the signal in the monitor bus stereo image. Then we have the fader tray section, where we have the fader controlling the level onto the main monitor bus and familiar solo and cut buttons. Below this, but only on channels 1 and 2, we have the insert button, and this allows the insertion of analog outboard equipment onto the recording path for inputs 1 and 2. To do this, outputs 9 and 10 must be reconfigured as insert sends via the SSL 18 settings menu. If the insert button is greyed out, then this hasn't been configured, so jump into the settings menu here to configure them. Next then we have the MON button that routes the signal onto the monitor bus. If you're looking to monitor your input signals with near zero latency via the SSL 18 mixer, don't forget to press this button. And finally, for the fader tray section, we have the stereo link. By clicking on either O, 2 odd even paired channels can be stereo linked and will be converted into a single fader stereo channel. Note that these controls only affect the playback of the signal via the monitor bus and won't affect the signals recorded into your DAW. Now, a very cool feature of the SSL 18 mixer is the mirror out, which allows you to route any physical input, Aux Master bus or monitor bus directly to a physical output. By clicking in the mirror out drop box at the bottom of the channel, a pop-out list will appear. Then from this list, you can choose the physical output you would like to route that particular input to. The mirror routing system can be super useful for situations such as configuring SSL 18 as a straightforward analog to digital converter, where you could route each analog input to an ADAT output if using SSL 18 as a mic pre-expander. You could also use this to feed the inputs of a personal monitoring system, external hardware metering units, or external FX units like reverbs or parallel compression. When using the mirror out feature, it's important to remember that any output you configure as a mirror output will overrule that particular output from the DAW. For example, if you're using ADAT output 1 as a mirror route, any signal you attempt to route out of ADAT output 1 in the DAW will not work until you remove ADAT output 1 from use as a mirror route. Select no route to remove your mirror route and free up the physical output to be readdressed from the DAW. At 44.1 and 48 kHz, mirror routes from analog and digital input channels can be pre or post fader. At 88.2 and above, mirror routes are always pre-fader. At any sample rate, Aux Master mirror routes are always post-fader. Moving to the right side of the analog inputs is the built-in Talkback input channel, allowing communication directly to the headphone mixes and feed into the DAW for creative recording and mixing purposes via the switchable listen mic compressor built into the Talkback channel strip. This classic analog compressor circuit was originally used in the SL4000B console for communication purposes, to help hear what the musicians in the live room had to say before and after a recording take. In use on the Talkback input, it can be helpful to ensure that the producer sat on the sofa at the back of the room can be heard when the engineer is talking back to the artist who's recording. However, the heavily compressed sound is also great for creative uses, such as connecting a microphone set up in the live room as a smash drum kit room mic, or switch the Talkback input to line mode and reprocess sterile DAW stems through the LMC circuit for extra mojo. So looking at the top of the channel again, we have the input meter, indicating the incoming signal level to the channel, where again the red segment at the top of the meter indicates clipping. Next to this, we also have the listen mic compressor meter, indicating the amount of compression being applied to the input signal where the LMC is engaged by the green LMC toggle switch. Like the other analog input channels, we also have the plus 48 volt phantom power available to power any Talkback mic that requires phantom. The mic gain has 3 fixed mic gain settings available at 30, 40 and 50 dB. Above this, we can instead switch to the line input for a pre-amplified Talkback mic signal or to reamp signal from your DAW. Next then, we have the same routing to send the Talkback to headphone A, B and line 3 and 4 outputs, with the same controls as the other analog input channels for level, pan and mutes. We can also rename the Talkback in the scribble strip, useful if we're reamping for creative purposes. Then below, the Talkback Engage button labelled Talk, which when illuminated green will send the signal to the routed aux buses. This can also be engaged from the SSL18 front panel. The red fader is an overall trim control for the Talkback sends to the buses, so for example if everyone needs more or less Talkback in their headphones. It's important to note that the Talkback signal will always be sent to the DAW regardless of the state of the talk button, but only if you have selected Talkback in the 9 to 10 input source drop-down on the right-hand side of the mixer. Following from the analog inputs, let's open up the digital inputs section from the View tab, and this is where we can see that SSL18 can also accept a pair of SPDIF and up to 16 ADAT channels as digital inputs that can be routed in the same way to the headphone and line 3 and 4 monitor outputs, as well as utilising the mirror routing functionality too. The digital inputs provide no gain controls, so gain should be set on the external devices connected to the inputs, but polarity control is still available for incoming signal, as well as stereo ganging channels for even pairs via the linking at the bottom of the channel fader tray. It's worth noting that the number of ADAT I/O channels available will depend on the sample rate that you're working at. When using 44.1 or 48 kHz, all 16 channels will be available, dropping down to 8 at 88.2 or 96 kHz. Don't forget that you'll need to use the second set of optical ports on the rear of the ADAT channels 5 to 8 when working at 88.2 or 96 kHz. Alternatively, you can use the second set of optical ports for SPDIF if you need SPDIF on optical rather than coax. Open the SSL18 settings and configure the SPDIF interface drop-down to your preference, remembering to power cycle the unit to apply the change. Next in the view options, we have the Playback Returns. The 4 stereo Playback Return channels allow separate stereo signals to be sent out of your DAW or other programs with assignable audio outputs into the SSL18 mixer as inputs. Eagle-eyed viewers will notice that DAW outputs 5 to 6 won't enter the SSL18 mixer, but these can still be used as hardware outputs for external processing chains, routing them directly from your DAW or software program. At the top of the channel next to the meters, the Direct to Bus button allows each stereo playback return to bypass the main section of the SSL18's mixer routing matrix, and instead the signal is sent directly to the corresponding Aux bus master as denoted above the DIR button. On Playback 1 and 2, engaging the DIR button will send DAW outputs directly to the monitor bus and then via the monitor control knob to outputs 1 and 2. Enabling mix routes off will prevent any audio sent from the DAW or audio playback software on outs 1 and 2 from reaching the physical outputs 1 and 2. Similarly, selecting DIR for playbacks 3 and 4 will send DAW 3 and 4 outputs directly to the SSL18 line 3 and 4 Aux Master, outputs 3 and 4, bypassing the routing matrix. Enabling mix routes off again will prevent any audio sent from the DAW or audio playback software on outs 3 and 4 from physically reaching outputs 3 and 4, again because playback streams 3 and 4 always passes through the SSL18 mixer at the final stage before reaching the physical outputs. With direct-to-bus on Playback Returns 7 and 8 and 9 and 10, engaging the DIR button will send DAW 7 and 8 and 9 and 10 outputs directly to the headphones A and B Aux Masters, bypassing the routing matrix. Enabling the mix routes off will prevent audio sent from the DAW on outputs 7 to 10 from entering the SSL18 mixer. Physical outputs 7 and 8 and 9 and 10 will be unaffected and still receive signals sent from the DAW on outputs 7 to 10. This is desirable if using outputs 7 and 8 or 9 and 10 for hardware inserts. When the direct button is disengaged, the signals can be routed to the headphones A, headphones B, and lines 3 and 4 bus from the SSL18 mixer. As with the input channels, sends to the aux buses are controlled by the headphones A, headphones B, and line 3 and 4 send level, and the scribble strip also able to be renamed if desired. The fader beneath each playback return channel controls the level sent to the monitor bus, as well as providing solo, cut and pan functionality, and finally the mon button routes the signal onto the monitor bus. The playback returns can also be set to mono or stereo linked as indicated by the green infinity symbol. Now we come to the Aux Master section of the mixer view, which consists of headphones A, headphones B, and line outs 3 and 4 master outputs. Each Aux Master bus consists of a large signal metering section with a resolution of 0 dB down to -60, and all share the same fader tray controls. Top left, we start with a sends post, which when selected sends levels to the aux buses from the channels that will be post fader level. Next, follow mix 1 and 2 overrides the Aux Master input so that it follows the monitor bus mix, providing an easy way to send what you are listening to on the monitor bus to headphones or outputs 3 and 4. AFL, short for After Fade Listen, allows the user to monitor the aux mix on the main outputs, ideal for quickly listening to the artist's headphone mix. And next, cut mutes the signal output of the aux channel, mono switches the output to mono, sewing both left and right signals together, and the fader sets the master level of the aux bus, keeping in mind that this is pre-physical gain control on the SSL18 front panel. Then at the bottom of the channel we come to the mirror out, whereby clicking on the mirror out drop box at the bottom of the channel causes the pop-out list to appear. This, similarly to the input channels, allows the aux bus output to be routed to any of the output channels on the interface. This will take precedent over any other routed output signal such as DAW output routing, but allows the channel to be set up as a post-fader direct output of the interface. The line 3/4 Aux Master has the same parameter controls as the headphone Aux Masters, but with the addition of the link unlink button at the very bottom of the fader section. This allows you to treat line 3 and line 4 as independent mono mixes. Finally, we come to the master out channel. This is the monitor bus feeding your monitors via outputs 1 and 2 or outputs 3 and 4 if alt speaker is enabled. The master fader level will control the output volume signal pre-physical monitor level control on the SSL18 interface. And the mirror routing is also available as a post-fader send to any available physical stereo output, useful for feeding external hardware metering devices, for example. So now we've seen all inputs and outputs of the SSL18 mixer, let's check out the extensive monitoring section. Down here in the bottom left, we see the controls, with a dim engaged for attenuating the monitor outputs, set by the dim level here at the bottom. The dim level can trim from 0 dB to -60 dB when turned fully counterclockwise. Next, we have the cut that mutes the monitor outputs, followed by mono, summing the left and right outputs to your monitors. We then come to the polarity invert button of the left side signal, allowing us to assess the phase relationship between the left and right signal. Next, below there, we come to the alt speaker enable button. This function allows you to connect a second set of monitors to line outputs 3 and 4, and when alt speaker is enabled, the monitor level will also affect the output signal level to outputs 3 and 4 when the alt button here is engaged, and will transfer the master bus signal to outputs 3 and 4. Then finally, we come to the alt speaker trim knob that allows gain adjustment to offset the output levels sent to the alt monitors connected to outputs 3 and 4, allowing the levels to be adjusted between the main monitors and the alt monitors, so the monitor control doesn't need to be changed when A being between two different sets of speakers for a more accurate comparison. Next up, we have the settings menu, which contains all configuration options for the interface. We can access this from either the settings button on the left of the mixer or via the cogwheel above the monitor section. Starting with the headphone output options, we can select this to be either headphones mode or line output mode if we want to use outputs to feed audio signal or CV signal to external units via the headphone outputs in the front panel. When operating in headphones mode, you can choose between 3 different options by selecting an option from the drop-down menu. Standard, the default setting, and is suitable for a wide range of headphones. High sensitivity, this most being applicable for use with certain in-ear monitors, IEMs, or headphones that have especially high sensitivity. Typically, this would be for headphones that specify their performance at 100 dB per milliwatts or higher. And finally, high impedance. This setting is ideal for high impedance headphones, which requires greater voltage drive to produce the expected output level. Typically, headphones with an impedance of 250 ohms or greater will benefit from this setting, so check your headphone specs to find the most suitable headphones mode for your make and model. And always make sure, before you switch your headphones output to high impedance, to turn the front panel level control down to avoid accidentally overloading your headphones if you are unsure about the sensitivity you're working with. When working in line output mode, the headphone ports are configured as monoline outputs instead of stereo headphone outputs. By default, these are balanced, but you can make them unbalanced by clicking the unbalanced box. Next up, we have the insert settings. By selecting Use Line Output 9 as Insert Send 1, repurposes the physical output labeled 9/1 send from its normal operation as output 9 and moves it to the input stage of the analog input 1 for use as an insert send. When we use this in conjunction with Insert Return 1 physical input, this allows you to insert analog hardware into the record path for input 1, which is great for tracking with and committing to analog compression when recording into your DAW. This is exactly the same for output 10 as Insert Send 2, with output 10 moving into the input stage of analog input 2 via the Insert Return 2 physical input connection on the rear of the interface. If analog inputs 1 and 2 are stereo linked in the mixer section, then the insert will pair line outputs 9 and 10 together, allowing a stereo insert to be used across inputs 1 and 2. Great for master bus processing, or an alternative connection for line inputs 1 and 2 to be connected to the rear of the interface. Next, we have the SPDIF interface options. This drop-down menu will allow you to select the SPDIF interface input between optical and coax connections available on the rear of the SSL18, and power cycle is required to apply changes made here. If selecting optical, the optical in and out ports too should be connected to your SPDIF device. The options here determines how long the peak hold segment of the SSL18 software mixer holds for, selectable between no peak hold, 3-second hold, or hold till cleared. Another cool feature of the SSL18 are the customizable options for the channel functions for 3 buttons labeled Line, High Pass Filter, and 4K on the front panel. In the Settings menu, each button can be reassigned to an alternative function, choosing between Line, High Pass Filter, 4K, and Polarity Invert, giving the option to change these controls to suit your workflow. The next section allows us to switch the operating level for main outputs 1 and 2 and line outputs 3 and 4, switchable between +9 dBu and +24 dBu for correct gain staging for different monitor operating levels or outboard effects processors. Outputs 5 to 10 are fixed at +24 dBu, perfect for integrating professional studio outboard equipment. Then below this, we have the mono-sum compensation options, determining the compensation level for mono-summed buses, adjustable between -3 dB and -6 dB. Now we've checked out the settings menu, we can look at the I/O mode, available here in the top left of the SSL18 mixer. When clicking on the tab, we open the I/O window, bypassing the SSL18 mixer's routing matrix and fixes the routing as shown in the table below. We still have the ability to choose the input source for inputs 9 and 10, choosing between Loopback, SPDIF, or Talkback. We can also still freely choose which output pair headphones A and B are fed from by clicking on the desired circle. I/O mode can be used for different purposes, such as simplifying the operation of the unit when you don't need the full flexibility of the mixer routing, or if you require end-to-end 192 kHz performance. Now let's move on to the profile section. We can save and load customized profiles for the SSL18 mixer to help speed up our workflow and quickly move between different routing options for different scenarios. To save a profile, simply press Save As and name your new profile, which will be saved in the SSL18 folder for easy recall. To load an existing profile, simply press the Load button, which will then open a new window to all the saved profiles and can be easily selected by pressing Open. The default storage location for both Mac and Windows operating systems is shown on screen, although they can be saved and stored from any location. If you want to jump to a blank slate, just click on the default button to return SSL18's mixer to its factory-shipped default state. Back over now onto the right-hand side, we have the user buttons that can control the functions of the controls assigned to the 3 buttons on the front of the interface. By default, the user buttons are assigned to match the printing on the SSL18 interface front panel, which are cut, alt and torque. But with a right mouse click on any of these buttons presents a menu whereby you can change the assignment of these buttons. We can now choose between dim, cut, mono sum, alt invert phase left, talkback on off, meter source and 360 SSL18 GUI, now accessible from the front panel. Below the user buttons, we can now move to the control section. This section displays key information in setting up your interface ready for working within your DAW. The sample rate drop-down menu allows the user to select the internal sample rate that the SSL18 is operating at. The selection allows for 44.1 kHz, 48 kHz, 88.2 kHz, 96 kHz, 176.4 kHz and 192 kHz. Alternatively, the sample rate can be set from the audio MIDI setup on Mac or the SSL USB control panel application in Windows. Below this, we then come to the clock source menu. This allows you to determine your preferred clock source, whether that's internal clock or external via ADAT or SPDIF. When choosing to clock from an external ADAT or SPDIF device, you cannot change the sample rate from the sample rate box here, but instead you must change the sample rate on the external device being used as the clock source. Next up, we move down to the Loopback Source. This option allows you to record USB audio back into your DAW, great for streaming and content creation, and can be particularly useful for recording audio from software applications or media players. To set this up, first ensure 9 and 10 input source is set to loopback. Then select the Loopback Source channel you wish to record from your drop-down menu, for example Playback 1 and 2 to record the output of a media player. Then in your DAW, select the input channels as input 9 and 10 and record the audio as you would with any other input channel. But be sure to mute the recording channel in your DAW to avoid creating a feedback loop. Next we have the 9-10 input source selection, allowing you to select the input source for DAW inputs 9 and 10 between loopback, SPDIF and talkback. Here we can switch the front panel meters between inputs and outputs, changing the display on the front of the interface as required. And finally, the Solo Clear button allows you to quickly clear any active solos or AFLs in the SSL18 mixer. When any channels have been put into solo or AFL, the Solo Clear button will illuminate yellow. Now, if you need any helpful reminders about any of the functions of the SSL18 mixer, we can use the Contextual Help to add a useful tooltip explanation to any parameter function when hovering the cursor over the control. Another really cool feature of the SSL18 is that every output on the interface is DC coupled and able to send plus or minus 5 volt signal to allow CV control to semi and modular synths, Euro rack and CV enabled outboard effects. We can use Ableton CV tools to seamlessly integrate Ableton Live with various devices to send clock, run stop signals or even LFOs to modulate external effects in real time, and we can record back the audio into our interface for total studio integration. For more information on getting your SSL18 set up with CV tools and DC outputs, check out the user guide where we go into more detail. And there we have a complete run through of the SSL18 interface and 360 mixer. Thank you so much for watching, and we hope you found this useful in getting started with your new interface. Remember, for more information on the SSL18 and access to drivers in the user guide, you can find these on the SSL18 product page on the SSL website, as well as more information on all our products on solidstatelogic.com.